Division by the largest, just make a quick section on division by largest unique digit and repeating digits after decimal place. After decimal place. Note that the earlier Vortex Sum corresponded to the remainder and repeating number after the decimal place. If you had 11, this Vortex Sum is 1 plus 1 is 2, and 11 divided by 9 is going to be 1.22222, and here 2 divided by 9 is also equal to 0.22222. And similar over here is the 6, 7, 8, the Vortex Sum is 3, and then 6, 7, 8 divided by 9. 9 is again the highest digit in the base 10 system. Equals 75.333. The remainder is 3 over 9, which is 0.33333. So 3's, these all line up. The repeating digit is a result of dividing by the highest unique digit of a number system. In this case, in this case, it's 9 for. It is 9 for base 10. So, for example, let's look at this one. So, base 10 has the 10 digits. So, 0, 1, 2, 3, 4, all the way to 9. The 9 is the biggest one. And now, if we look at, just look at an example here. We'll go 3 divided by 9. We could write this out, again, using the fraction method, fraction long division, and so on. But we could write this as, if you multiply top and bottom by 10, so we could write this as, let's write this as 3 over 9. Times it by 10 over 10, so then this equals 2, and just rearrange it, move the 10 on the front side. So 1 over 10 times, and this is going to be 3, 3 times 10 is 30, or just leave it as 3 times 10, like that. Or actually, furthermore, we'll just move this 3 out of there, actually. Leave the 3 there, move the 10 on this side, move the 9 on this other side, just switch these places. So we're going to have a 3 over 10 times it by a 10 over 9. So we have this scenario. And now we could write this as our 9 plus 1, so the highest digit 9 plus 1 for base 10. So we can write this as 3 over 10 times it by 9 plus 1. 9 plus 1 over 9, like that. And now what this equals to, this equals to 3 over 10 times it by, now this splits up. So 9 divided by 9 is just going to be 1. And then plus the remainder there is 1 over 9. Like that. So now what do we have here? So what we have here is this 1 over 9. If we multiply this 3 over 10 inside, this is going to equal to 3 over 10, just expand it, 3 over 10 times 1. Then plus 3 over 10 times 1 over 9, which equals to 3 over 90, or I'll just put it as 3 over 10 times it by 1 over 9, like that. Or even better yet, just move this 3 and 1, replace them, so move this like that, and it's 3 over there. Where we already know what 3 over 9 is, that's just this scenario. That's this 3 over 9 is 3 over 9. That's just a starting one, so we just plug this back in. So we get a loop. So we have a continuous loop like that. So then this is going to equal to, well, 3 over 10 is just 0.3. 10 just divides moves it over one decimal place. This is going to be 3 over 10 plus, 3 over 10 plus, and this is going to be 1 over 9. And then replace 3 over 9 with this 3 over 10, put this in a bracket like this, times it by 1 plus 9 over, 1 over 9. So we can just keep repeating the same procedure. This is the same thing as this whole thing. We just moved it over there. And now if we expand this out, this is going to equal to 0.3 plus, this is going to be 1 over 10, multiply that inside. We're going to have a 3 over 100, multiply this 1 inside, it's going to be by itself. And then plus a scenario where now we're going to have move this inside, so move this all the way inside here. We're going to have, so 1 over 10 times 3 over 10 is going to be 3 over 100, and then over here 3 over 100 times 1 over 9. So we're going to have a 3 over 100 times 1 over 9, or just move this 3 inside. Just switch the 3's. Switch them over like that. So and now this is the same thing. We keep throwing this inside. We're just going to have this more and more. And where this 3 right there, or this 3 over 100, that just equals to 0.3 plus 0.03 plus, now we have another 100 times by 3 over 9. And it just keeps repeating on. And again, I just cycle this back in there. See, these are all the exact same things. Just cycle it back in, and we're going to eventually have it as add these up. 0.3 and 0.03 is going to be 0.33 plus 1 over 100 times 3 over 9, and you can keep repeating on and on. This equals to plus 3, 3, 3. Yeah, 3, 3, 3, keeps going on. And if you put a line up here, it just means the 3 is going over continuously. And also notice here that this one here, just for completeness, this would be equal to, is 3 over 9 is going to be, again, 3 over 10. So you always increment by, this 100 becomes 1,000 and so on. And then this is going to be plus, 3 over 10. Put this like that, 1 plus 1 over 9. And so on. And it keeps going on and on. You can keep going on forever. And so there's nothing unique about this 3. We can just replace 3 with 1, 2, or whatever up to 8. And what we'll see is this, up to 8, which is just before 9, where you get an even division, or a whole number. So we can replace 3 with any integer 0 to 8 to obtain the following repeating digits patterns. So right here we have 0 over 9, this is just 0, or you can consider it as 0.0000. That's a special case. Or if you have 1 divided by 9, so just replace 3 with 1. Replace 3 with 1, all you're going to get is just a 1 there. So it's going to be 1, 1, 1, 1, 2 divided by 9 is 0.0222, etc. And you can even see this, you just press equal and it automatically calculates as that. And it cuts off there. But yeah, so you keep going on and on. So 8 divided by 9 is 0.88888, and then 9 divided by 9 is just 1. So that you start there. And a similar pattern is expected for base 5 or any base number. So base 5, the digits are 0, 1, 2, 3, 4, and the biggest digit is 4. So if you have, let's say, 1 over 4 now, we can write this as, just for completeness, multiply the top and bottom by 10 over 10. So this equals to 1 over 10 times it by 10 over 4. So this doesn't change anything. I just write it like that. So times the top by 10 divided by 10. So it doesn't change anything. So now we have this, write this in our usual notation for the highest integer plus 1. This again is base 5. So this is going to be written as 1 over 10 times it by 4 plus 1. 4 plus 1 is equal to 10 or 5, but we're in base 5. So 4 plus 1 is 10 or 1, 0. And then divided by 4. This equals to 1 over 10, and then divide this all out. 1 plus 1 over 4. So there's the cycle. That's much simpler. Yeah, much simpler than that 3, but it doesn't change anything. Just a 1 there, there's 1, 1. And multiply this out. This is going to be equal to 1 over 10 plus 1 over 10 times 1 over 4. And now we just repeat the same exact cycle. Throw this inside. Throw this whole thing inside. This is equal to 1 over 4. So then we could just throw this inside. Whoops. So we could just throw this inside this 1 over 4. And then we get the exact same pattern. 1 over 10 is just 0.1. And then plus another 1 over 10. And this is going to be square bracket 1 over 10 times it by 1 plus 1 over 4. And then this becomes, expand this out, 0.1 plus 1 over 100. Multiply that inside, plus 1 over 100 times 1 over 4. So in other words, this is going to be a 0.1 plus a 0.01, then plus this part right there, and you can keep going on and on. 1 over 4, like that. Let's write this a bit neater. Yeah, so we could write this out, and then this is just going to be 0.1111. Again, you could keep replacing this entire thing, put that back in here, and keep going on and on. The next one's going to be 1 over 1,000 times 1 over 4, and so on. This can be non-stop. Alright, so now summarizing for base 5, we have 1 over 4 equals 0.111, 2 over 4 is 0.222, 3 over 4 is 0.333, and then 4 over 4 is just going to be, 1, because that's just a whole number. So in general, if we have base n, and then we have 0, which is the number 0, 1, 3, 4, 1, 2, 3, 4, 5, 6, etc., all the way to p, where p is n minus 1. Then 1 divided by p is equal to 0.111. 2 divided by p is 0.222. 3 divided by p is 0.333, etc. Or p minus 1, so the second largest digit, divided by p is again equal to 0 point, and then p minus 1, p minus 1, p minus 1, and then it keeps going on forever. And then p divided by p is just 1. And there's some pretty interesting stuff indeed. So let's continue Further, so MES Convention, Vortex Sum versus Digit Sum. Note that whenever I refer to, quote, Vortex Sum, I'm referring to the continual digit sum until a single digit is achieved. So if we have 98765, then what we have is V equals is a digit sum. Yeah, that's a digit sum. So we sum the digits 9 plus 8 plus 6 plus 5. Then we write V equals, yeah, so then this equals to, well, actually we need to sum this first. This equals 28. You could just write equals of 28. This is a digit sum. And then we could go V equals again, so 2 plus 8 equals 10. Actually, yeah, this is not the vortex sum. This is going to be, again, V equals 1 plus 0. Yeah, 1 plus 0. This equals to, yeah, this equals to 1. Which is the vortex sum and digit sum. Whereas this one is, this is just, again, another digit sum. So yes, digit sum just refers to any time you sum the digits, and vortex sum refers exclusively to the final single digit of the base number system.